Hi, this is a supplementary lesson for Algebra 1, lesson number 78 on closure. And so I just wanted to go over maybe a more simplified explanation than the book's explanation of closure. First off, so how to answer these questions, you're going to go ahead and put ASMD in capitals as you're part of your answer, and you're either going to put a slash through each letter or a check mark above it like they did in the book to indicate if the set is closed for that particular operation. And so I am going to be going off of the textbook examples on lesson 78, page 282. If you want to turn to that right now, I'll be doing example 78.3 and 78.4 at the bottom of that page as an example. So if you want to pause the video and open your text to that, you can. Okay, so real quickly, what are we doing? All we're doing is we're going to state for a set of numbers, and here we have a small set, 3 numbers inside the braces, -1, 0, and 1. Okay, is the set closed for these particular mathematical operations? Addition, subtraction, multiplication, division. In other words, if we perform an operation with any of the numbers in a set, any of these mathematical operations, are the solutions confined to the set as well? If we say all possible solutions for the operation are confined to that set, we say the set is closed then. It's closed to any other possible solutions other than -1, 0, and 1. Okay? If we find a possible solution that is not -1, 0, or 1, then we say the set is not closed for that operation. Or you could say it is open, think of it as an open close sign. If it's not closed, it's open to other possible solutions other than what's in our set. Okay, so 2 procedures to do it. If the set is small, you can just try every possible situation scenario to see if you can come up with an exception. And that's what we're trying to do. We're trying to find one exception, and that's all it takes to say the set is not closed for that operations. Okay, if the set is a large number of numbers, okay, we can't possibly try every scenario. If it's the set of integers, okay, that's an infinite number of numbers. Okay, it's 0 and every positive integer to infinity. It's 0 every negative integer to infinity. So what we'll want to do in that case is just kind of come up with a sampling of numbers. And so I would take one that's like really big in the negative region, one that's really small, negative. Always pick 0, okay? Pick a small positive number, and maybe a medium or a large number. You would only have to do maybe 5, to kind of test out and find different scenarios. So kind of 2 different ways to handle it. If the set's small, we go through and find out all the possible scenarios. Let's try it for the small set. For the operation of addition, can we add 2 numbers in the set? Can we find an exception? Okay, the textbook goes right to the number 1. Number 1 plus 1 is 2. And you can use the same number, still using the same number, the number 1, and adding a number from that set, the same number, number 1. 1 plus 1 is 2. Is 2 a member of that set? No, it is not. Okay, so there are other possible solutions for addition outside of that. So we put a slash through it and say the set is not closed for the operation of addition because there are other possible solutions other than -1, 0, and 1. Okay, subtraction. Can we think of it? And again, the book goes to the example. If we take 1 and we subtract a -1, a 1 minus a -1 is the same as 1 plus 1. It equals 2. Again, we have a possible solution that is outside the set. For subtraction, the set is not closed for that operation. I don't know if you can see that original slash mark. I'll make it a little darker. Okay, let's try for multiplication. a minus 1 times a minus 1 is 1. That's in the set. A minus 1 times a 0 is 0. A minus 1 times a 1 is a minus 1. Okay? A 1 times a 1 is 1. A 0 times a 1, 0. Okay? Every possible scenario using those integers multiplied together comes up with one of those three numbers. So that we put a check mark and say, for the operation of multiplication, the set is closed to other solutions. It is only these three solutions right here are possible. Okay, so see how that works? We can't find an exception. We tried all the different variations. And for division, and that's one of the more simpler ones, because if 0 is a member of your set, when we take any number divided by 0, it is undefined, okay? And so undefined is not part of that set. In fact, it's not a number, it's undefined. So if we ever have 0 in our set, okay, division is automatically out of the game because there are other possible solutions or outcomes other than those three there, okay? So if it's a more complicated set, a bigger set of numbers, we just have a couple more different variations to check out. And a lot of times it's not actually going through and doing them, as just kind of thinking, okay? So for the set of integers, I took these as my sample numbers just to kind of think. Now, there's a lot more numbers in the set of integers than these, but these are just my sample numbers I'm going to look at. And when you pick one, try to pick a big negative number, a big positive number, a small negative number, a small positive number, and 0. And try to as well mix in even numbers and odd numbers, as I've seen there. Excuse me, drop my chalk. And that will help you out. So let's think of addition. Can we think of any two integers in the set we can add together where it won't be an integer? Okay, and we can kind of think, just looking at these numbers, we add any of those together, they're going to become an integer, okay? And we can't really think of an example, okay, where that's the case. And in fact, any integers added together are going to result in an integer. It'll either be a positive number, a negative number, or it will be 0. And of course, every positive number, every negative number, and 0 are a member of the set of integers. And that's the same thing for subtraction. If we subtract any two, multiplying, let's think about it. We multiply two negative numbers, it's a positive integer. We multiply a negative and a positive number, whether they're big or small, it'll be a negative number. When we multiply any number times 0, it's 0. We can't think of an exception where there's a solution outside of the set of integers. Okay, so we say the set is closed to multiplication. All possible answers will be within the set of integers. And again, division, that's an easier one. We can use that same rule. Okay, we divide by 0. We'll get that. Also, we could also think of an exception. If we take that integer where I have here 3 and I divide it by my other positive integer 10, I get 3/10. 3/10 is a fraction. It can't be reduced. It can't be expressed as a whole integer. Okay, it is a real number, it's a number, but it's a fraction, a quotient. Okay, it's not a member of the set of integers. So we have two examples, two exceptions we've found with division. So we would slash through that and say the set is not closed for the operation of division. Okay, so that's how we go through these problems. Your answer form will be that ASMD with check marks above it or slashes through the letters to indicate closure or not closed. Okay, so I hope this helps. Shoot an email with a question or a text message if you have any questions or comments. Bye for now.